Okay, good morning, everyone. As usual, how do you guys have any questions about the homework before we do some review? Okay. All right. If you guys don't have any questions, I will start doing some reviews myself. And if you think of anything, just put it on chat. Don't 18 and 34 on final review. Okay, 34. Okay. All right, we look at those two problems quickly and then we proceed. So it's number 18 and 34. So number 18 tells us the following. You have a differentiable function f. So we have a function f. So that's number 18 on the review. Okay. So we have a function f, and I'm giving you that. I'm giving you that the value of the function at 3 is equal to 5, and the derivative at 3 is equal to 2. So what I'm doing is I have a function, that's 3. I'm giving you the value of the function, so that's a point, that's 5. I'm telling you the derivative is 2. So that's the derivative. And out as I'm giving you that the function is concave down. So the function is concave down. That's the picture I have. Okay. And so it's not a straight line. So my function is actually not a straight line. And the question is, use the differential to estimate the change in f. So it means if you basically move a little bit here, that 3.05, the function is changing. So that's the change in y. And the idea is use differential or the idea of linear approximation to estimate the change in y. Okay, so let's see how we do this type of problem. Okay, let us remember that. This basically boils down to definition of the derivative. The change f of 3.05 minus f of 3. Let us remember, if I do the following, if you ever forgot the differential, let me tell you where the idea is going to come from. That's divided by this. So if you remember this difference quotient, this is nothing more than the slope of this line here. That's the slope of this line, okay? And this is almost equal, not quite equal, this is almost equal to the derivative at 3, okay? Where is that coming from? Because basically, what is the derivative? The derivative is nothing more than you take those quotient, those basically the slope of the secant line, and then you get closer and closer to the point, and you take more secant line. And the limit of that is what we call the derivative or the slope of the tangent line. So f at 0.5 minus f divided by this, which is the slope of the red line, is almost equal to the slope of the tangent line. So it means that the change minus f of 3, that's the change in y, is almost equal to the derivative. I'm going to multiply by that times 0.05. So it means the change in y is almost equal to f prime of 3, which is 2, times 0.05. Now this is what we call the differential. This is called the differential. So the differential that we call dy is basically the derivative at the point times the delta x. That's the delta x, that's the change in x. And that's really the derivative at that point. That's what we call differential. But where is the idea coming from? That's really what the basic idea is, that the slope of this line, the red line, is almost equal to the tangent line. That's really where the idea coming from. That's really the definition of the derivative. So if you multiply across by, so this is 0.05, multiply across, we get the change is almost equal to that. So it means that the change in y is almost equal to 0.1, almost equal to 0.1. Okay, almost. Now we look at number 34. And then I proceed. Number 34, what is it about? Right. Use definite integral to find the area under the graph of the function f of x equal 1 over x. So this is my function, 1 over x. So this is f of x equal 1 over x. This is 1. And this is e. And we need to find this area using definite integral. All right, now what does definite integral tells me? Integral from 1 to e of 1 over x dx. So the function is positive. The function is positive. So the area is given by the definite integral, because, as I always repeat, the area is nothing more than the sum of those rectangles. That's really what the definite integral is. So now we have to evaluate this. Antiderivative, use the fundamental theorem. This is the ln of x evaluated between 1 and e. So it's equal to ln of e minus the ln of 1. ln of e is 1 minus 0, which is equal to 1. So that's the area. Okay. I'll take your Chris's question, number 10. Number 10. Okay. Number 10, good question, because you most probably have something along those lines on your exam. So let's look at number 10. The graph of a function is given to you. That's the graph of my function. Okay. First question is, find the value where f prime equal to 0. Okay, when is the derivative equal to 0? Quickly, answer me on chat, because I'm sure you're going to have problems along those lines. You have to know this stuff. Okay, when is the derivative 0? Quickly. You guys have the review in front of you, because this is not very clear. Are you with me? Anybody, any answer? When is the derivative? That's the graph of the function. When is the derivative equal to 0? It means when is the slope horizontal? The slope horizontal here. Derivative is 0 here. And the derivative is 0 here. So that's when the derivative is equal to 0. So if I look at my graph, that's for x equal -2, it seems to me. And for x equal right here, so -0.1, -0.2, -0.4 almost. And finally here, almost 1.3. I'm at 1.5. Yeah, but now concentrate on that. Okay, concentrate on this problem. Are you with me, guys? Yeah, I'll look at all your questions. Concentrate on this. Now, find the value of x when f double prime equal to 0. When is the second derivative equal to 0? When is the second derivative equal to 0? Wake up. When it switches sign. When what switches sign? It stands for what? So there are it. What does the it stand for?
When the concavity changes.
I can't hear you.
When the concavity changes.
Exactly, when the concavity changes. Now, where does the concavity changes? Here. It changes right there, right? And it seems to be changed. You guys now are giving me the answer. It seems to be changing somewhere here, right? So the concavity changes at -2. No, a little bit more. -1.2. That's what you guys are giving me. And it seems to be changing at x equal like 0.8 almost, or 0.6, something around 0.6. You guys are right. Okay, very good. Now, sketch the graph of f prime. All right, so the f prime is positive, is 0 at here, at the when this horizontal, when the slope is horizontal, and the second derivative is 0 at the inflection point. Now, finally, sketch the graph of f prime, and we're gonna do our best to sketch the graph of f prime. Okay, so let's see how we're gonna sketch the graph. Okay, so this is f. We're gonna sketch f prime. So, okay, so now how the derivative is changing. The first point, as you remember, first we actually focus, all right, when is the derivative 0? Because those will be our guidelines. So this is when the derivative is 0. And right here is when the derivative is 0. And then we start analyzing it step by step. Up to here, what's the derivative doing? Okay, the function itself is decreasing. The function itself is decreasing. If the function is decreasing, it means my derivative is negative. Okay, and if we look carefully, it's getting less and less and less negative. That's the concavity is telling me that's getting less and less and less negative. So it starts somewhere here, the derivative, and then it's negative, it's getting less and less negative, heading towards 0. That's what it's doing. Now, between this point and that point, between the two zeros, what's the derivative doing? Okay, the derivative seems to be, so first the function is positive up to here. So, the function is increasing. It means my derivative is positive. I mean, we follow really the tangent line. And how is it doing? At the beginning, when the function is concave up, as we realize, the derivative increases, gets more positive, but then when it changes concavity, the derivative is getting less and less positive, heading towards 0. Okay, so the derivative is positive, getting more positive. Actually, it's at the inflection point where it starts changing. Because watch, when the function is concave up, the derivative actually is increasing because the slope gets larger. When the function switch and is concave down, then the derivative start getting smaller because the slope gets smaller. So it's going to increase, and at some point it's going to stay positive but decrease. Now, between the two other zeros, from here to here, again, the function is decreasing, causing the derivative to be negative. But now let us watch how the derivative is going down. At the beginning, it's getting more negative, but then it stays negative, but it's less negative, heading towards 0. So it's going to be negative. It's going to be negative. And then, let me see, so this, okay. It's going to be negative, but then at some point it changes and stays negative, but less and less negative. And the changes really occur at the inflection point. The changes really occur at the inflection point. Because if you take a function which is concave down, let's say concave down, and we draw the slopes gets more and more negative. Actually, they are decreasing. When it is concave down, when it's concave up after that, then if you realize the slopes are getting less and less and less negative. Finally, from here so on, the derivative is positive, it's getting more and more positive. End of the graph. Okay, good, you guys asked this question. All right, now let's see, now I go back. To number 10, I'm done with it. Could we go over the questions from the homework? Yes, Elijah, which question? Oh, but I have to pick up the book. Yeah. What's the question, Elijah?
I'll try and find it.
Okay, then I will go to 7.
Oh, I found it. I found it.
Okay, please give it to me.
It's just the antiderivative of 1 over the square root of 4 minus 49x squared.
Did I give that problem?
It was on like the Pearson My Lab homework.
Don't worry too much about it. Okay, in 164,
Okay.
we will learn how to do it. That's an arc sine. This is basically because the person wants you to use the table, and I didn't want to do that yet.
Okay.
Remember, I don't know if that's
so. This one isn't.
Yeah. This is actually based on this integral. This one is the arc sine.
Okay.
Okay, and this we have to do some kind of substitution to basically get the arc sine of x over 7, something like that, okay? So the reason I didn't, because I wanted you to use the table. I don't want you to use the table yet. I think it's too soon.
Okay.
We will learn how to do those. I mean, you guys will learn in calculus too. So I don't want to jump to tables yet. We have plenty of time to do.
All right, good.
All right.
Because that one I was.
Oh yeah, absolutely. You're absolutely right. There is no reason for you to know how to do that. This is substitution. We have to take away the 4, and then we're going to have 49 over 4x squared. So it's going to become like this, and then we're going to make the substitution u equals 7 over 2x. By doing this, I will have that integral. That's basically the idea. Okay, so I keep going with your other question then. I have the 7, either A, B, or C. So 7, what is 7 about? 7. This is the implicit differentiation. Now, if my memory is correct, it's usually it. I did A in class last time. I remember you guys asked me, so I will do C. Okay, so I don't want to do A. If you go through the previous lecture, you will find A. The Tuesday, Wednesday lecture, I think I did A, so I will do C. And in my review yesterday for exam 2, also I did the one on the exam. So hopefully this would refresh your memory for those problems. So use implicit differentiation to find that. Equal x cubed y cubed, okay? The basic idea here is to remember that y is a function of x as usual. I keep repeating this. But we don't know how to solve for it. Okay, we don't know how to solve for it in a way. So the question is how to find the derivative. As long as you keep in mind that there is not a y here, there is a function of x. And this is not a y intuitively, that's a function of x. You will be, I think, all right. So the way we proceed is that, okay, we say the derivative of the first equal to the derivative of the second. Okay, so that's really how we start. And then we start differentiating. So derivative of x cubed is just 3x squared plus derivative of y to the power 3. As I said, it's not really a y in here. It means a function of x. What is f, I really don't know. So it is a function of x. So when I'm going to find the derivative of that, so I'm going to find the derivative of this, we actually have to use the chain rule. So that's the inside is the f and the outside is u to the power 3. So this is going to give me 2 times f of x squared times the derivative of the inside. And that's really the concept I'm using here. So my f is the y. So it's going to be 3 times y squared times y prime. That's the derivative of this term. This is equal to the derivative of x cubed y cubed. This is a product. Whenever you have a product, you have to use the product rule. Okay, product rule tells me is again the derivative of the first 3x squared times y to the power 3 plus x to the power 3 times the derivative of y cubed, which is again, we did it a minute ago, that 3y squared y prime. Now we have basically to put the y, we have to solve for y prime. So we put everything in y prime together. And then everything, the constant term together. And we solve for y prime. Okay, now we solve for y prime. So we factor y prime out in here. Okay, and then y prime, we divide both by the coefficient of y prime, or but y prime is multiplied by. Remember, y prime is nothing more than, in other words.
I have a question.
I'm listening.
Why would the 3y squared minus 3y cubed x cubed for on your left?
Which line?
The second to last one.
This one?
It's minus. Yeah, why would it be minus? I thought it'd be plus considering.
Did I do anything stupid? Any stupid mistake?
Wait, okay.
This is 3y squared. I'm right with that. Okay. This one is minus 3y squared x cubed y prime. 3. That's correct, right?
Oh, okay. Okay, sorry about that.
No problem, because I do stupid mistakes, so there is no question.
All right, thank you.
Okay, then we get y prime. All right. I think I answered all your questions. Now what I would like to a little bit talk about is your quiz 8, and I know exactly which problems you guys struggled with. Okay, quiz 8. The first question was estimate using midpoint sum with 4 subdivision and illustrate graphically. A lot of you did not illustrate graphically, even though I've asked you to do that. So what do I mean illustrate graphically? It means this integral here, how can we visualize it? Okay, when we approximate with midpoint sum, what are the midpoint sum graphically? And a lot of you must stop here. So 1 plus x squared is this function. Now we have to be careful with the boundary. It's 1 and 3. Also, some of you just basically ignored the 1 and the 3, and they subdivided, I don't know, in integrals that I couldn't understand. That's the 1 and the 3. And basically the integral, because my function is positive, is going to represent the area under this region. So that's the area here. Now in the midpoint sum with 4 subdivision, I need to divide the interval 3, 1 into 4 pieces. So my delta x here become 3 minus 1 over 2, which is going to give me, I meant over 4, of course. It's going to give me a half. So we divide it into 4 pieces. Okay, these are the 4 pieces. And then my question is to use midpoint sum. Okay, midpoint sum, it means I take the following rectangle. The height is the value at the midpoint. So I take the midpoint, that's my height. And then my rectangle, this is the height of the rectangle. So even though some of you knew there is something going on in the middle, but I didn't exactly get what it is. This is the height. The height is the value at the midpoint. Again, here, I take the midpoint, and then we're going to find those midpoint. This is not the hard part. That's you guys had. And this is the rectangle that we're going to use to approximate the area. And finally, this one. So that's the point. The height is up to here. That's the height. So that's my rectangle. It doesn't go up. It doesn't go down. That's the height here. And the base is always the same. So that's the base. This is base not changing. And finally, right there. Okay, that's my last one. Okay. And now we need to find the midpoint sum. So I need to find those dots, those red dots here. So we're going to find them. Some of you use the formula, which is fair, by taking, so some of students, of course, they saw it somewhere, and so this is a 2 in here, and this is 3/2 in here, and this is 5/2. Okay, so some students just use the formula, which is To find the midpoint, you average those two. It means you take 1 plus 3/2 divided by 2. Okay, you can do that, of course. So let me say what I'm talking about. So some students, they said, okay, x1 star, which is the first point, is the average between the two endpoints over 2. Okay, and if you average those two, you get 3 plus 2, you get 5 over 4. So that's one way you can do that, which is actually just a formula. Some students usually just looked at it, which is usually what I would do on most of the time. So I said that from here to here, you have, because this is a half, so it means from here to here, you have 1/4. So basically you have a 1 from here plus a 1/4 from here, which is gonna give you the 5/4. So that's really another way. And then we keep going, the x2 star is gonna be, okay, 5/4, you're adding a half to it or 2/4. So 5/4, so you're gonna get 7/4. So this is gonna be the 7/4. And then we keep going. So the x3 star, you're adding again, is a 2/4 to it, which is gonna give me 9/4. And finally, the x4 star, I have only 4 rectangle, you're adding another 1/2, it means another 2/4, you're getting the 11 over 4. And the midpoint sum is M4 is the height, which is F at 5/4, times the width. And then we proceed. 5.94 plus and so on and so forth. I felt I missed something. 9 over 4 times a half, and finally 11 over 4 times a half. And then you compute, there were no problem with computation. Okay. Now part B, I did not really put any grade on it because it was very clear to me that there were a misunderstanding in the question, which is fine. We write this as limit of right Riemann sum. What I only actually wanted you to be able to do is write this as the following Riemann sum. It's a sigma. We're adding those. That's the idea. We take the interval between 1 and 2, 1 and 3, and we divide it into n equal pieces. That's really the idea. And then we compute the height at the right end point times the width. That's really what we do. So how we're going to write this is, in general, is the value of the function at the right point times the delta x, and then we add those from 1 to n. And then we take the limit, and this is, we have trouble with that, when the number of subdivision goes to infinity. That's the, in general. Now, in my case, actually, it's going to be the same. So this is the limit as n. It's the limit when the subdivision, number of subdivision goes to infinity. That's what n represents, the number of subdivision. Now my f is 1 plus x squared. So this is going to be 1 plus xi squared times the delta x. In my problem, the delta x is the 2 over n. So if you write 2 over n or you write delta x, I will accept either one. What I really want is for you to be able to see this integral as actually limit of those type of sums. Part 2, again, there were issues with that. Number 2, the issue is that, remember, the definite integral is the area, if the function is not positive, its function take positive and negative value, is the area of the region above minus the area of the region below the x-axis. It depends where the function is positive or negative. So in 0, 2, so the first thing I ask, before I just plug a number, I look. That's 0 and 2, 0 and 2. I'm looking for the definite integral. Between 0 and 2, my function is negative, all of it negative. So this is going to be minus the area of, now I'm going to write it in word, this is R1. It's minus the area of R1. It's minus this area. That's really what the definition will lead me to. Because when I will be adding those f of xi times delta x, I will be adding minus the area of those rectangles. Okay. Now what's the area? At this stage, I just compute the area. So I forget about anything. Now I am back to area. That's a triangle, so it's half the base. The base is from 0 to 2. So the base is 2 times the height. The height seems to be 2. So this is going to be minus a 2. Minus a 2. It's minus the area. Okay, definitely there were trouble in this problem. Now, from minus 4 to 0, that's the bound. First, I focus on the bound because that's the piece we're basically splitting into pieces to find the sum. And right here, my function is positive all across. Everywhere between minus 4 and 0, it's positive. This is where we're taking the sum of the area because f of xi times this is area. Now, I told you that that's a half circle. So this is going to be half, now the area of a circle pi r squared, pi times the radius squared. Now the radius here turned out to be a 2. And that's going to give me half times pi times 4, which is going to give me whatever 2 pi. Because the function is positive, is plus the area. Now the last one is from minus 4 to 4. I go back to my graph. What is minus 4? So the first thing, as you realize, first I see what are my limit of integration. Up to 4. A lot of you went to 5 and to 6. No, you have to go up to 4. Exactly what the limit tell you. Minus 4 and 4. That's the interval we're splitting. We cannot go further up to here. Now, what's happening here? Between minus 4 and 0, the function is positive. So we're going to have the, so let me call this region here. Okay, I call this R1. I'm going to call this R2. From here to here, the function is positive. So it's positive the area of R2. Okay. Now, between minus 4 and 4, sorry, between 0 and 4, my function is negative. So I'm going to take minus, and because I call this R1, I'm going to call this one in red, let us say R3. Just because I called the first one R1. Minus the area of the region below the x-axis. It means minus the area of R1 plus the area of R3. Okay. Now we find it. The area of R2 is 2 pi. Minus. Now the area of R1, it's 2. Area R2 is actually the same thing. It's 2. So it's 2 pi minus 4. All right. So there were a lot of misunderstanding in this problem. So please review it. What else? I have comment. This was exam with good comment. All right, in here, the only mistake that I usually encounter is that 1 over 5x squared is 1 over 5 times x to the minus 2. Some students tend to write it like this, which is wrong. And number B, my memory is you guys did fine. That's my memory. So it's 1 plus x squared. So there are 2 ways of doing it, times x to the minus a half dx. And then the mistake that a lot of you still do actually is basically the algebra. So when you distribute, you get x to the minus a half. X squared times this will give you x to the power 3/2 dx. Okay. And this one, the fundamental theorem, the mistake that some did is they did not find the antiderivative, period. I mean, they just took the integrand and they evaluated. First, you have to find the antiderivative and then you evaluate. End of the problem. All right. I guess I am almost done. Unless you guys have any questions, please go over review 3. Crucial. I mean, exam 3 is crucial for you. So you have the solution on Blackboard, on Brightspace, I meant. Let me just talk a little bit about the first problem. And then I think I have to let you go. So find the derivative. Again, that's a product. A lot of you, I remember, missed that part. So it's the derivative of x plus x times the derivative of arc tangent f of x. So this is arc tangent f of x plus x times. And here we had some messing up. The derivative of arc tangent. Remember, the derivative of arc tangent is 1 over 1 plus x squared. So here my outside is the arctangent, and this here is my inside function. So this will have to be 1 over the derivative arctangent is 1 plus u squared, but my u here is the f of x times the derivative of the inside. So review that for those who didn't get it right. And then absolute max, absolute mean. Basically, we go after the critical point within my interval, and then I will, so because you guys have the solution. So first we find the critical point by setting the derivative 0. Setting the derivative 0 will give me x equal plus or minus 2. But now if my interval is 1, 4, it means the only critical point I care about is at x equal to 2. Once we do that, what we evaluate, and this sometimes you can get confused with, what we evaluate, if we evaluate f, some of you evaluated f prime. No, we go back to f, and we evaluate f at 1, f at 4, and f at the critical point. And then the largest value, here it happened, the function have its max at 2 different values, at 1 and at 4. So we have 2 absolute max, one at 1, one at 4, and 1 absolute mean. So the graph should have gone something like that. All right. Now the rest is basically, you guys have the solution, go over it carefully. The one that you struggled with for real was number 4, sketching. Please go over that. It's crucial that you can sketch. You do those number lines and then you go them step by step, step by step. What are the point that matters? So here we have f prime. I told you it's 0 here, it's 0 here, and these are the sign. I'm sorry, I have to take this phone. I'm very sorry. Okay, I apologize. It was a medical thing. I had to take up the phone. All right. So this problem, I would like you definitely to focus on it, to review how to sketch the graph is crucial. And if you have problem, let me know over the weekend. And that's it. Just go over the review. You have the solution. And at this note, I finished the class. Please, if you have questions over the weekend, please email me and I will try to help you. Okay, good luck for next semester and good luck on your exam. Go take your quiz.